are discussing pressure, no, from the very start. And on regarding pressure and diagram of vertical wall, since we know that a pressure is in the concept of gamma h, no, from our previous discussion on the pressure and head. So when we try to analyze pressure, so let's say this is the free surface, okay? So as we go along with the certain point, let's say P sub or A, and this is the certain height of that element from the free surface, okay, let's say that is height H or capital H. So the pressure at that point, P sub A, is gamma H. But since we know that as we go down with the element, the pressure increases. Let's say this is point number 1, okay, point number 2. So we could actually say that pressure number 1 is less than pressure number 2, and these pressure are both less than pressure A. Since pressure A is the highest pressure in relation to your height. It's the same thing with this force triangle or that pressure diagram here, the pressure triangle that you are seeing here, no, sa taas. That as we go along with the point or height, the base will be the pressure, or in this case, this is signified as rho g, or simply this is also gamma. Okay, so that is gamma or rho g h, and we know that, or we talk about the center of pressure, or C sub P, or P, in this case, in which doon nag-a-act yung ating resultant force. So, using triangle or area method, as presented here also, so that is equal to 1/2 base times height, since it is also equal to the resultant force. Ito po. That's why, resultant force equals to 1/2, the base is rho gh or gamma h times the height. So resultant force is equal to 1/2 gamma h squared. Remember, this gamma h squared is per unit width or length. Okay? Since if we notice that this gamma, let's say if it is in 9.81 kilonewton per cubic meter for water, for example. Okay, so let's say the height is, let's say in terms of meter. So if we multiply kilonewton, or yeah, for meter, so if it is squared meter, so squared. If we multiply that with kilonewton per cubic meter, ang lalabas na unit lang natin ay kilonewton per meter. That's why the resultant force is in terms of newton or kilonewton per meter or per unit width per length. Okay? So, to have a sample problem with that, let's answer this question. A closed tank rectangular in plan with vertical sides 1.8 meters deep and contains a water to a depth of 1.2 meters. Air is pumped into the space above the water until air pressure is 35 kilonewton per square meter. If the length of one of the wall of the tank is 3 meters, determine the resultant force on this length on this wall and the height of the center of pressure above the base. So, let's define first the given in the problem. So, as stated in this illustration, no, or given illustration, so we have the 1.8 meters deep na tank, the tank. Then we have the 1.8 meters deep of water. Ito po yun. In this case, it is stated that air is pumped into the space above the water until the air pressure is given as 35 kilonewton per square meter. So there are two possible scenarios that we could actually see in this one. So first scenario is air pressure will act, or let's say P sub A will act throughout the wall. Okay? Throughout the wall. So, sabihin lahat ng air pressure mag-act sa wall. And second scenario is air pressure, or P sub A, let's say in this case, will act only at the top of water. Okay? Since we know that from our previous discussion that if the air, no, since the pressure is somehow little, it will act throughout the wall, no? But in this problem, no, we could actually identify if it is the first scenario or the second scenario. Nevertheless, it will give an answer which is different from each other, na magkaiba po yan. In this case, ang sinabi dito ay, air is pumped into the space above the water until the air pressure is 35 kilonewton per square meter. Ito. Air is pumped into the space above the water. So, nandito lang talaga sa taas. And this height is equal to, if it is a 1.8 meter tank minus a 1.2 meter deep water, this is 0.6 meter. So, representing the pressure diagram, okay, so, let's say this is the height, okay, the 1.8 meter height, and then this is the 1.2 meters deep, halimbawa, ito po yon. So, we could actually say that in terms of water, so palitin lang natin tong illustration na to para medyo pumantay. Yan, dito na lang, yan. And so, again, this is the 1.6, no? Ito. 0.6 meter. Yan. So, if we're going to have this illustration, no, gawa lang tayo ng guidelines, para medyo makatotohanan naman yung ating pagpe-present. Yan. Okay. So, for water, so the diagram will be like this one. So, if it is the line o yung height, so, most probably, kung dito tinutulak niya, malamang yung kanyang pressure diagram ay papunta pababa, malaki sa baba, no? Let's say, pag ganito na lang, no, parehas lang naman yan. Okay. Ito. Yan. So, ito yung ating gamma H or rho GH, no? For water. This is for water. Ito, no? For water. For water. Then we have the height na 1.2 meters. Yan. Okay? Ito yung ating height. So, gamma H here is equal to gamma, this is 9.81, multiplied by height na 1.2 meters. Okay? Ayan po. Yan yung ating base, no? And that is equal to equal to 11.772 kilonewton. 11.772 Pascal or kilopascal. 11.772 kilopascal. Okay, that is because kilonewton per cubic meter yung ginamit natin. So, since we are dealing with the scenario, ng first scenario natin, ito, no, based dun sa ating problem. So, the pressure diagram for air will be just like this one. Ito lang. Okay. So, uniformly distributed siya kasi all throughout, no, on that length lang or on that height of that wall. So, if we are dealing with the gamma H of this one, no, or let's say meron na siyang pressure, no, P sub A or air, that is 35 kilopascal or 35 kilonewton per square meter. O, yun na yung kanyang pressure. O, paano natin yun compute? So, sinasabi sa atin sa problem, determine the resultant force, okay, and determine also the center of pressure, the height of the center of pressure. Let's say, H C sub P, no? From above the base, okay, from here, let's say, ito pa yun. Malaman dito papalo yung ating H C sub P na hinahanap. Okay? Yan ang mga pinapahanap sa atin sa problem. So, paano ang itsura ng mga forces ng ating mga pressure? So, para sa air, since it forms a rectangular section like this one, so mag-act siya dito sa gitna niya, no, for air. Let's say R sub A. And the height relative, no, from the base, sabihin galing sa base, ay mula dito hanggang dito. And that height is equal to 0.6, ito, no? Ito yung height na yon. 0.6 over 2 plus 1.2 meters. Ayan yung height na yan. And then, for the water, okay, for the water, so since alam natin from pressure diagram na mag-act ito, saan daw? Sa 1/3 or 2/3 from the tip or 1/3 from the base. So, nandito yan. And then, this is the resultant force. Okay, for the water, RW na lang. And then, this height is equal to, since from the base, no, 1/3 times 1.2 meters. Okay? Now, the question is, since we are dealing with resultant force, and we know, no, from the formula from pressure diagram, let's have a quick recap on that, that R for certain, let's say, kung ano man yung element na yun, water, mercury, or kung ano man yung fluid na yun, gamma H squared over 2, remember, this is per unit width or area lang, or unit length or width, to a respective area. So, if we want to know the resultant force, really, no, ng walang per unit length or width, we should multiply this to that length or width na hinahanap natin. In this case, that sa problem binanggit na if the length of one of wall of the tank is 3 meters, ito na yon. So the length here is equal to 3 meters. So we could actually now compute for the values of R sub A and R sub W. And R sub and total reaction, easily we could actually see here that is equal to R of water plus R of air. Okay? So answering that, so let's answer that question. So using this diagram, we could actually first compute for the R sub A. For R sub A, yan, tapatin na natin yung R sub A para sa air, that is equal to pressure times the projected area. Okay. R sub A is equal to the pressure 35 kilonewton per square meter multiplied by the area. No, projected area that is 0.6 meters multiplied by the length 3 meters. Okay. It will give us the answer na, ano yung sagot yan? That is equal to 63 kilonewton. So this is for R sub A. Okay? So for R sub water or para sa water natin, so using the idea ng pressure diagram, balikan lang natin tong illustration. Ayan. Since we know that it forms a right triangle, so pwede natin gamitan ng 1/2 base times height na area. Okay? Para sa resultant force. That is equal to 1/2 times the base. Ano ba yung base natin? That is gamma H. Okay? So, gamma H times the height, H. Yan. Times the, since we are dealing with per unit length, ito kapag ito yung ating ginamit lang, so times natin sa length na binigay, which is 3 meters. That is 1/2 times gamma 9.81 times H, or let's say H squared na lang. So, that is equal to 1.2 meters squared times 3 meters. So, will give us the answer na 21.19 kilonewton. Okay. So, we have the R sub A and RW. So, now we could compute for the resultant. Now, for the resultant, that is equal to R sub A plus RW for water. So, R is equal to R sub A, 63 kilonewton, plus 21.19 kilonewton. So, it give us the answer ng R na equals to 74.19 kilonewton. Yeah. So, this is for our reaction. Ito na yung value na yon, yung nakuha natin. Now, the second unknown na kailangan natin mahanap is the height or HC sub P. So, sabihin pala, dito nag-a-act, no, yung ating resultant force, saan daw? Or let's say, i-assume natin na dito muna. Yan. So, baka nandito nga, no? Baka lang, no? I-assume lang natin yung R. Hindi pa natin alam yung height, eh. Pero we know already the value of R. So, using the Varignon's theorem, okay? So, balik tayo doon sa solution natin. Ito. So, gamitan lang natin ng Varignon's theorem. That is R multiplied by HC sub P plus R sub A. Ano yung height niya? Binanggit natin, is equal to, yan. Ano nga ulit yung height ng ating R sub A? Yan. So, balikan lang natin yung illustration. So, R sub A is 1 half ng 0.6 plus 1.2, that is equal to 1.5 meters. No? 1 half ng 0.6, 0.3 plus 1.2. So this is equal to 1.5 meters. Ito naman, equal to sa 1/3 ng 1.2 meters equal to 0.4 meters. Okay? So, R sub A is may height na yung kanyang pressure na 1.5 meters. Tapos sa water is may height na from the base na 0.4 meters. So, if we're going to rewrite, this is equal to 74.19 multiplied by HC sub P is equal to R sub A, ayan, 63 times 1.5 plus 21.19 times 0.4. So, we will have the value ng ating height ng ating resultant force or height ng ating center of pressure mula dun sa ating base. Yan, sige. The answer for this one is equal to 1.39 or 388 meters. Okay? Yun yung answer natin, no? 1.39, okay, or 1.388 meters from the base no? From the base. From the base ng ating tank. So, kung babalik natin yung illustration, so, lalagpas pala doon sa ating water, no? Parang nandito pala talaga yung ating resultant force. Kung ito yung 1.2, nandito pala talaga yon, no? Dito napunta yung ating resultant force kasi ito yung 1.388. Okay. So, yan yung ating answer, ito, for this particular problem. So, yan. Itong dalawa na to. Okay? So, that is for pressure diagram for a vertical wall. Now, if the case is naging inclined yung ating pressure or yung ating diagram, so we will just use lang yung ating sine or cosine, no? Depende kung anong angle yung tinutukoy sa ating problem. Okay? So that is for pressure diagram for a vertical wall.